This is your teacher, Dr. Usama Kashfa, and this is a lecture of measuring. We will measure here. We'll talk about now if we have two different averages. Testing the equality of two population means. We will test the equality of two population means. Case that we have also the standard deviation of the population, or we don't have, we have the standard deviation of the sample. We will check out the tests of both of them. So let me go and share the screen now. Let me share the screen, then we will see how to get the measure of the hypothetical testings for a sample with the standard deviation of the population, and another sample with the standard deviation of another example for the standard deviation of the sample. So we'll have both of them and check out how is the difference between both of them and how it works. Now in front of you here is for the sample. Let me write it down on the board here. How to measure both of them. Then we will go through that. After that, we will go to an example. So let's go first and see. I'll stop sharing and I will put my notes. That's my notes. That's fine. Okay. So if we have the standard deviation, if the standard deviation of the population is there, that's fine. We'll say that the measuring of two population means we are testing the equality of two population means. Okay, perfect. Then if sigma of the population, we know that this is the sigma. Okay, we know now that this is the sigma. If the sigma of the population is known, then the relationship will take this way, or it will take this figure. Sigma of the population is known. Okay, if sigma of the population is known, we will say that this will equals x bar z. Then z will equals x bar 1 minus x bar 2 divided by the root of square of sigma 1 square divided by n1 plus sigma 2 square divided by n2. So this will be the case if sigma is known. But if sigma was not known, and I have the sigma, we said, is the standard deviation of the population. If I don't have the standard deviation of the population, and I have the standard deviation, now I don't have it, I don't have this, but I have the standard deviation of the sample, this for the sample. STDEV, this is for the sample. So if I have the standard deviation of the sample, all I will do, just I will move the sigma 1 square and put S1 square, and sigma 2 square, I remove it and put S2 square. So in case that, like I said before, I will write it here. If I have sigma is known, or sigma is unknown. Okay, so I will write it all on the board here, and after this we'll apply it, just a small example, then we'll apply it, it will be right. So if now sigma is known, and sigma we mean by sigma the population, sigma population is unknown. So if sigma is known, the relationship will be x bar 1 minus x bar 2 minus x bar 2 divided by, this is known, the root square of sigma 1 square divided by n1 plus sigma 2 square divided by n2. This is if sigma is known. But if sigma is unknown, situation will be different. I will use S instead of n, instead of sigma, sorry, instead of sigma. So it will be x bar 1 minus x bar 2 divided by the root square of sigma 1 square divided by n1. This will be S because I'm working on the sample, the standard deviation of the sample. Okay, plus S2 square divided by N2. Oh, okay, this will be the rule. Some books, they write here in this area, as long as this is not x bar of the mean, they write it like this, mu1 minus mu2. They write it like this, mu1 minus mu2. That's fine, because you know sigma, so to signalize between, to make a distinction between sigma, between the average of the population and the average of the sample. So M, like the average of population, and S is the average of the sample. X bar, sorry. X bar is the average of the sample. So they use this as example here. I know the average of the population, then I will make it M1. M like this, 1 mu, u1. And mu2, okay, for the other population. So here we know now what we came to know today is that we have the to measure the means of two averages together. So we will use this relationship. Either the standard deviation was known for the population or not known. And we have here the first example, which we'll use it now. I will share the screen to get this example. Then I will move directly to my own example here. Let's say example, a factory bought two bulbs that are A and B. Okay. A sample had been taken out of the 100 units. Wait a minute. This is sample. Then the sample is 100 units. Okay. More than 30. But I have to wait and see which formula I will apply. Am I going to apply sigma or apply S? Still, I didn't know. Units of each one was found that the average time of working life was, so this means this will be in the sample because I took the sample of 100 and the average in the sample. So I won't use mu. I will use X bar. Okay. So here, okay, a bulb is 1,140 hours for the bulb. Knowing that working life was in each bulb a random variable of mu and it was 100. So here I have the mu and I have the standard deviation of the population. I have the standard deviation of the population because they give it to me here. Mu and sigma square and mu and sigma square here. So that will be now fine. That will be now fine. I will apply the how to get my test, the Z test, and calculate it based on the Z. In this example, it's different because here is working on the sample. I don't have, but this one is very important because I'm working here on the population set. Anyhow. Now, I have mu1 and I have mu2, but I have it in the samples here. A and B sample had been taken of 100 units. Okay, so my sample is 100 units. Now I will go to unshare the screen to watch. Okay, and we'll go for the example which is in front of me here and solve it. So what? So let us see the example is saying what? A factory bought two bulbs that are A and B. Okay, we have two bulbs, and we want to see the difference between the function of the two bulbs. Are they the same or no? Had been taken out of 100 units. This is the first thing I will get. 100 units, then N will equals 100. N, let me put the data here. N will equals 100. Okay, this is in the sample. For that reason, I put N, small n. Okay. Was found that the average time of working life was the average time in the sample. This is in the sample, was 160. Okay, so this is in the sample. The X bar 1 equals 1160. 1160. Remember, this is average. This is average of sample. This is inside the sample. And that's 1140 for the bulb 2. So x bar 2 is 1140. Again, this is the average of the sample. The sample, I give it x bar. Okay. Then was taken for life. If the bulb is having a random variable with a distribution of mu1 and okay, this kind of distribution. When I say mu1 and 8100, this is means mu1 and sigma square. Sigma 1 square means like this. So sigma 1 square will equals 8100. Sigma 1 square. Sigma, but wait a minute. This is for the population. So sigma 1 square will equals 8100, and sigma 2 square, sigma 2 square will equals 6,400, and I have to apply the formula now. Okay, is there any doubt? Doubt means I'm expecting that I will investigate unequal. As long as the word doubt, then unequal, I will test unequal. That the bulbs don't differ in working life, examine at alpha equals 5%. So alpha equals 5%. Like you see always in the hypothetical tests, every line I do, I take from each line I'm working on, I take from some indicators, like some, I take from it a result, a data. I would take from it a data. That's fine. Now I have the whole data of the whole example. All I will do now is the formulation of the of my own hypotheticals. Okay. Then I will say now, x bar 1, I did all this. I have the, so I will apply now. I would say how I would solve it. Then I will do first like we did, hypothetical nil, m mu1 equals mu2, because I'm seeing now two averages of two means. H1, because he say doubt, then I would say m1 does not equal m2. If he said greater, then this will be greater. If it's less, then this will be less. Okay, according to the claim. Then the test tool, I'm discovering this at alpha equals 5%. And this is two tails, of course, two tails test, two tails test. How I know that it's two tail test? Because of the unequal. Make it two tails test means that I will check for the critical area in between the two parts of the normal distribution curve. Then here I will do the test. My test here, I will use what? I will use Z test. Why I will use Z test? Because sigma there. Z will equal x bar 1 minus x bar 2 divided by the root square of sigma 1 square divided by n1 plus sigma 2 square divided by n2. So when I apply this, when I apply it equals x bar 1, I have it. X bar 1 is 1160 minus x bar 2 is 1140, right? Okay. Divided by the root of sigma 1 square. I have sigma 1 square 8100 divided by n1. n1 is how much? n1 is 100, because both the samples was 100. n1 equals n2 equals 100, because he said we took sample of 100 from both of them. So we took sample 100 from n1 from the first population, and we took a sample 100 from the second population. So this will goes to, when I calculate all this, this will be, Z will give me 1.67. 1.67. Perfect. After calculation like this also, sigma 2 square, I said sigma 2 square is 6,400. Yeah, sigma 2 square, 6,400 divided by n2, which is 100. When I'm done for all this, calculation, it will give me 1.67. So now the fourth step is comparison. The comparison, which I will compare Z tabulated with Z calculated. When I see Z tabulated, alpha equals 5% and two tails test, when I go to discover it in the Z table, I will find it that Z tabulated, Z tab, when I find it, alpha 5%, two tails will equal 1.96. Will equal 1.96. But the Z calculated, which I calculate here, equals here 1.67. Then the decision after the comparison, that means decision, the last step, decision or the last step, decision or the last step, since Z tabulated is greater than calculated, then accept H0. Accept H0 means the average of the societies are the same, which I'm studying. So the two bulbs are living the same life. There is no differences between the life of the two bulbs. Because of what? Because the calculated is 1.67. Let us do the curve here again, the normal distribution curve. And we will say that you accept H0 till 1.96. Till 1.96, this is two tails. You accept this is a positive and this is a negative. You accept it, 1.96. But the problem is here in the middle. Okay, the calculated is 1.67. Calculated is 1.67 means it goes inside within. It is within the tabulated. It is here. 1.67. Look at this, it's here inside. So as long as the tabulated is less than the calculated, then we will accept H0. H0 is telling what? That there is no differences between the life of the two bulbs. Means that the bulb number one will live same life as example 100 years or 200 years working like the bulb number two. So this was how to test the means and the averages of two different samples in the same time. I wish you a good night. Thank you so much. Please watch the video once and twice and 3 and 4 times till you get full aware of it. Thank you so much. Have a good night. Bye-bye, everyone.